these problems, we're going to go over what they mean by solving a system of equations by graphing. What they want you to do is they want you to take these two lines, these two linear equations, graph them on the same graph, and find the point they intersect. Now remember, if they don't intersect, if they're parallel, you write down no solution. If you happen to have the exact same linear equation, then the answer is infinite solutions. On these, they're probably all going to intersect at a single point. So what we need to do first is graph each one of these, and then we can determine where they intersect. So we're going to start with this bottom one right here. First thing, figure out what form it's in. This one says y is equal to 3x minus 1. That's in slope-intercept form. The way you graph something in slope-intercept form is you graph the y-intercept first and then use the slope. The y-intercept is negative 1, so on the y-axis I go down to negative 1, put my first point. Then I'm going to use the slope. The slope on this one is 3. Most of the time we use the slope as a fraction. That would be 3 over 1. 3 over 1 is telling me to go up 3 since it's positive, 1, 2, 3, and over 1. I can continue to do that to generate even more points on this line. 1, 2, 3, over 1. 1, 2, 3, over 1. Then I use my ruler, draw my first line. Now I'm going to graph the second line. The second line is also in slope-intercept form. That means I graph my y-intercept first, and then I use my slope to generate more points. So my y-intercept on the black linear equation is negative 2. So I'll go down to negative 2. Then I'm going to use my slope. My slope is 4. 4 written as a fraction is 4 over 1. That's telling me to go up 4 over 1. So we're going to do that from this point right here. 1, 2, 3, 4 over 1. Since I already have a point that they intersect, I'm going to go ahead and draw that line as well. When they are asking for the solution, they want to know the coordinates of this point that they have in common, where they intersect. So that's what we need to write down. We need to write down the coordinates for this. Remember, coordinates have parentheses. My x is the first number. I go over 1. Make sure I put a comma. I go up 2. This right here is the solution for this system of equations. This point is where these two lines intersect. These numbers are the only numbers that have solutions for both of these. We need to solve this system by using graphing. That means we need to graph each one of these. I'm going to start with the red one. I look at the red linear equation and I determine what form it's in. It's in slope-intercept form. That means I need to use the y-intercept out here to graph it first, and then the slope. Since I don't see a number out here, that means my y-intercept is 0. That's where I put my first point. Then I use the slope. The slope is the number in front of the x. What number is in front of the x? A negative 1. I need to write it as a fraction. That would be negative 1 over 1. That's telling me to go down 1 from this point and over 1. Down 1 over 1. Down 1 over 1. I can keep using that slope to generate points on this line. Once I generate enough points, I draw my red linear equation. Now I'm going to graph the black linear equation. It's also in slope-intercept form. I need to graph my y-intercept first. It's negative 1. Then I need to use my slope. My slope is negative 1/2. That's telling me to go down 1 over 2. So from this point right here, I'm going to go down 1 over 2. I already have a point in common, so I'm going to draw my black linear equation. The answer to this are the coordinates for this point right here. So let's go ahead and make an open parentheses. My x coordinate goes first, 1, 2. My y coordinate goes next, down 2. The answer or solution to this is the point where these two lines intersect. So make sure you write it as a point with an x and y coordinate. Our next problem, I need to solve this by graphing. I need to figure out where these two lines intersect. I'm going to graph the red one first. This is one of those special lines. It's either a horizontal line or a vertical line. It says y is equal to 4. So I know I'm going to put my first point on the y-axis at 4. 1, 2, 3, 4. Right there. In fact, since it only has a y, it is not going to run into the x-axis. So I need to draw a line that never runs into the x-axis. That would be a horizontal line. So here's my horizontal line. This is the graph for y is equal to 4. My black linear equation is not in slope-intercept form. It is in standard form. To graph something in standard form, I need to use the x-intercept and the y-intercept. So I'm going to write it twice and find each of those. I'm going to start by using the x-intercept. If I use or need to find the x-intercept, I don't need the y. And this tells me x is equal to 6. So that's where I put my first point on the x-axis. So 1, 2, 3, 4, 5, 6. There's my x-intercept for this black linear equation. I need to find the y-intercept. If I'm finding the y-intercept, I don't need the x. I solved this little equation right here by dividing both sides by 3. Y is equal to 2. My y-intercept on this is 2. So what I'm going to do is I'm going to go up 2, 1, 2. I'm going to draw my black linear equation. And then I need to find the coordinates of the point where these two lines intersect. And it looks like it would be that one right there. I need to write down the coordinates for that. I make my parentheses. My x coordinate goes first. 1, 2, 3, 4, 5, 6. Since I'm going backwards, that's negative 6. And then I'm going to go up 4. The answer to this systems of equations is negative 6, 4. You write it as a point, as an ordered pair. I'm going to solve this systems of equations by using graphing. I'm going to start with the red one first. I look at this linear equation, this red linear equation, I look and see what form it's in, and I can tell it is in slope-intercept form. The way you graph something in slope-intercept form is you graph the y-intercept first, and that's what we're going to do. We're going to graph the y-intercept, which is positive 1. Then I'm going to use the slope. Here's the slope. That's telling me to go up 5 over 3, and I'm going to do that from this point right here. Up 5, 1, 2, 3, 4, 5 over 3. 1, 2, 3. Go ahead and draw my red linear equation. Now I'm going to graph the black linear equation. The black linear equation is in standard form. To graph something in standard form, I need the x-intercept and the y-intercept. So let's do that. Or find that by writing this twice and finding each of those. To find the x-intercept, I do not need anything associated with the y. That says x is equal to 9. That's where I'm going to put my first point on the x-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I need to find the y-intercept. If I'm finding the y-intercept, I don't need the x. I solve this simple equation here by dividing both sides by 3. The y-intercept is going to be negative 3. 9 divided by negative 3 is negative 3. This is my y-axis. 1, 2, 3. I go to negative 3 on the y-axis. And I draw my black linear equation. I now need to find the coordinates where these two lines intersect. These two lines intersect at this point right here. I need to find the coordinates for that point. Go ahead and make an open parentheses. 1, 2, 3. I went back 3, so my first coordinate is -3. 1, 2, 3, 4. I went down 4. My y coordinate is -4. This is the ordered pair that is the solution to this system. This is where they intersect. These are the numbers that are solutions for both of these. We need to solve this system by using graphing. These two are those special types of lines. We're going to start with the red one. It says y is equal to -1. So since it says y is equal to -1, I'm going to put a point on the y-axis at -1. The red one does not have an x in it, so I need to draw a line that will never intersect the x-axis. And the only way I can do that is by drawing a horizontal line. So the red equation is a horizontal line. Now I need to graph the black linear equation. It says x is equal to 3. So on the x-axis, I need to put a point at 3. 1, 2, 3. Since this one does not have a y in the equation, I need to draw a line that does not intersect the y-axis. And the only way I can do that is drawing a vertical line. I need to determine the point where these two lines intersect. Open parentheses, go over 3, that's my x-coordinate, go down 1, that means -1 is my y-coordinate. This is the solution to this system. These are the numbers that work, and if you look, it says x has to be 3 and y has to be -1, and it is.